There. Okay.
No, I don't want you on the keyboard. You can go on the floor, but not on the keyboard.
I wonder if they ever have any echo problems inside space helmets.
Hmm.
Huh?
I have echo problems inside my head sometimes.
Join the club.
I have to say, I really admire the patience and restraint of everyone. I haven't seen this much quiet since the faculty senate meetings when I was an undergrad.
Okay, how about now? Can you hear me? Hello?
Yeah.
That's a yes, you can hear me? Okay, okay. Sorry about that. The technical difficulties. And that all came down to the mute button being on, on the screen. But we didn't think of something that simple. So, so let's start all over again. First order of business, I need to get a VP to do minutes for us.
Oh, there's silence.
Volunteers. I know that always quiets them down, doesn't it? Looks like it's between Dave and Jim. I could flip a coin if you want.
Well, maybe I should do it this time.
That was easy.
Yeah.
Appreciate it. Okay.
Hey, Dave, get the cat to do it.
There
Oh,
you
yeah.
go.
But you could do it.
He definitely wants to be involved. So, you can never start him too young.
Yeah.
Okay. So thanks, everybody. You have joined the University Lowbrow Astronomers August meeting. I'm Charlie Nielsen, the president of the club. And just to remind everybody, we are recording and going to upload this to YouTube later, sometime after the meeting. So, of course, as usual, we have to be on our best behavior, which is tough for us. So anyway, as usual, we are going to have our guest speaker talk to us first and then take questions. As I said in my club announcement, we also have another person, assistant director at the Detroit Observatory, that hopefully will be showing up here shortly. That's going to do a little shorter presentation afterwards, just about what's happening at the observatory there. But for now, we are going to bring up Karim Jaffer, who has been an astronomy enthusiast since early elementary school, living in rural Pennsylvania, which I imagine was some pretty dark skies. Many of our club members are involved in public outreach, but how many of us led our first outreach event at the age of 11? But Karim did. After moving to Canada during secondary school, Karim graduated with a Bachelor of Science and Master of Science in theoretical physics, but he withdrew from a PhD program to begin his teaching career, which was his real goal after all. Karim's academic path kept veering away from space sciences, a frustrating aspect to an otherwise rewarding schooling experience. After joining the physics faculty at John Abbott College in 2006, Karim finally got the chance to follow his interest in astronomy when the introductory astronomy course became available to teach in 2016. The course has a unique teaching method, which includes experiential learning opportunities with the local Montreal Center of the Royal Astronomical Society of Canada. This approach has led to the campus embracing astronomy observing activities, outreach, and astronomy-related projects in various disciplines, including other science departments and visual arts. Karim has been the public events coordinator for the RESC Montreal Center since 2016, helping reestablish their astronomy library and coordinating both public events and outreach activities throughout the Montreal area. Since embracing astronomy into his career, Karim has given conference and outreach presentations on a variety of topics in space sciences and education throughout Canada and the US. In addition to his volunteer position in the RASC Montreal Center, Karim is a member of numerous education and public outreach committees and panels. Plus, he has and continues to co-host and present at global star parties. So we're privileged to have Karim Jaffer joining us tonight for a presentation titled Two-Eyed Seeing, Indigenous and Ancient Stories of the Night Sky. And also Karim is a Lowbrow member, so I didn't mention that earlier, but we're honored that he's a member of us. So let's please give Karim a warm welcome.
Hi, everyone. I'm really happy to be here. Hoping one day I'll be able to be there in person. I've been a member of the Lowbrows now for almost a year with my family, and we've enjoyed attending a few of the meetings, which has been great. Thanks to Adrian for bringing me in. I've been on the GSPs with Adrian for a little while now. And as some of you may know, we actually just reached our 100th Global Star Party with Explore Scientific and the Explore Alliance. And we're still going strong. Last Tuesday was one of the first that I've missed all summer. Just too much to prep for with our college semester starts early. Sorry? Can everybody hear me okay?
Yep.
Fantastic. So as the intro indicated, I am a public events coordinator for the Montreal Center. So I'm going to start off by telling you a little bit about some of the outreach that we do. It's actually beyond Canada and the US now. I've been on this European group of outreach educators called now Space Oddities. We used to be Reach Out and Touch Space. And it's a panel show. So a lot of us come on, we share our perspective on different things happening in space science, in astronomy and exploration. And it's 3 p.m. Eastern Daylight Time every Monday, live on YouTube. We also will have special shows for certain events. We had a special show right after the James Webb Space Telescope images came out, where we went over the science of all of the images and we discussed each one a little bit in terms of what the image was showing us and also what we ourselves could see as amateur astronomers and astrophotographers, which was just a valuable insight to get from different people using different equipment and with different perspectives on what they find most important about the objects that we look at in the night sky. In the Montreal Center, we have monthly public events that we host these days on Zoom, but we will be getting back to in-person and co-modal, such as what you guys do on the Fridays. Our next one, I'm very proud to say it's my son, Elias Jaffer, who's giving the presentation. It's going to be next Sunday at 4 p.m. Eastern Daylight Time. And some of you may know about this program. I didn't know about it until last year when we came across the SOAR program at Mount Wilson. And it's a summer school on observational astrophysics research. And so he got to spend 2 weeks in July at Mount Wilson. He got to see the 100-inch, he got to see the 60-inch, he got to use the 150-foot solar telescope, and he got to do a research project while there. So he's going to talk a little bit about this whole experience, and it just sounds fascinating. He was the youngest person there. Most of the others were already graduated in their fields. There was one person who has been a teacher for, I believe, 10, 12 years, and they bring different perspectives into this historical site to work with this really old and new technology to do observational astronomy. The other thing that I'm really excited about to talk about going worldwide is next month, I'm going to be in Armenia as part of the outreach astronomers at Starmus Festival. This is Starmus 6. And on the Thursday night of that festival, we are going to be up at Temple Garni outside of the main city of Yerevan in Armenia, running a star party hosted by Explore Scientific. So I cannot believe I have this opportunity. I'm going with my wife, Karima, and my daughter, Tara. And some of you who have been attending the Global Star Parties have heard Tara's name because she's been doing a lot of outreach with me. She started her outreach at age 8, so she's got me beat. My son was 13 or 14 when he started doing a little bit of outreach, but my daughter has really kind of taken to this whole environment of astronomy outreach. So I wanted to share with you a little bit about what we see in the night sky and what our approach is to two-eyed seeing here in Montreal. And a lot of it is tied into the events that I hold, as well as the activities that I do with my students. So to give you an idea of Montreal, you can see here the light pollution map for the US and the southern part of Canada, the most populated part of Canada, which is right along the border. And right over there, that horrible light sink, that's Montreal. Now, I know Detroit is pretty bad for light pollution. I know lots of areas of Michigan are. Ann Arbor is pretty bad as well. Montreal, it turns out, is the third worst in the entire world per capita for light pollution. And part of the reason is because we are an island surrounded by both the St. Lawrence River as well as some mountains on either side. So it causes this amplifying effect for a lot of the year where we end up with a real amount of reflection of the artificial light within the city. We also have very poor light pollution policies. This is a nighttime view from the ISS taken by David Saint-Jacques when he was up on the ISS just a couple of years ago. And you can see just how bad the entire city is in terms of light pollution. But over there on the west part of the island, there's a small little bank of darkness, and that's where our observatory is located. It's the Morgan Arboretum run by McGill University, and we have a 14-inch telescope there on a fork mount. It's a Meade. It's a great little reflector. And right south of that is where my campus is. And this is the 2017 partial solar eclipse viewable from our campus. This was an event run by students the year after I had taken over astronomy and brought in this student-activated approach. And so we've really benefited from having the students and the society members really intertwined in a lot of our events. Our public events, you have both groups working together to make them a success. Our observing nights, you have both groups evident there, no matter whether we're doing first light for a 16-inch, whether we're doing library nights at our I.K. Williamson Library with the wonderful David Levy display there, or whether it's the students actually presenting some of the work and some of the research that they've done in class to other students and to the society members. It really is a reciprocal relationship that we have, a partnership between our society and the students at the college. Now, to give you some context, the college, John Abbott College, is kind of like a junior college. It's in Quebec, the province that I'm in. It's the equivalent of the last year of high school and the first year of university. And the astronomy course that I teach is a science option astronomy course. So it is quantitative in nature, but it's to a group of students that are just developing the basics for the fields of study that they want to go into in the sciences. So some of them will go on in space sciences, some of them will go on in physics or math. Most of them are going to go on in chemistry, biology, engineering, something along those lines. So one of the things I try to do is I try to showcase to them all the different careers that you can access through space sciences. So I don't limit myself to just observational astronomy or to astrophysics itself, although we do have a course on astrophysics. I try to give them a little bit of the breadth of everything that's available to them. And in doing so, we have this reciprocal nature where sometimes things that are happening within the college or within the student community comes over into the society. And one of the best examples of that is our land and sky acknowledgement. A few years back, a lot of you will remember that land acknowledgements started to become commonplace. Many public events, many presentations, many conferences started with a land acknowledgement of some sort, identifying that many of the lands that we're on are unceded Indigenous lands, unceded lands taken from the First Nations peoples of North America. So for us here in Montreal, it's the Mohawk and the Algonquin peoples who took care of the land before we came and kind of took it over and started using it. I expanded that with the discussion with the students in my astronomy course to a land and sky acknowledgement, because one of the things we recognized was that the sky is something that we share across the entire global paradigm. So there are individuals all across the world looking at the same things in the night sky that we look at as astronomers, whether it's in Michigan or whether it's here in Quebec. And so if we're looking at them with others from across the world, then we have to try to acknowledge the way in which they see the sky and the role that the night sky plays in their lives, in their culture, in the shaping of the way in which their communities have developed. And in doing so, one of the things that we recognized was that there's a lot of science and a lot of observation hidden within some of the otherwise just referred to as stories or legends. And that's where this talk comes from. It's trying to acknowledge and build from this idea that you really have observations and connections to nature hidden into a lot of these stories. And in gleaning them and bringing them out, we see that there's a lot of observation that was done that's identical to what we do now. So my first exposure to this came in 2019. Just as I was starting to do these land and sky acknowledgements, I learned about the Mi'kmaq Moons Project. The Mi'kmaq Moons Project is by one of my RASC colleagues, Royal Astronomical Society of Canada Halifax Centre, Dave Chapman, and Kathy LeBlanc of the Acadia First Nation in Nova Scotia. Now, what happened was Kathy was working at Kajikmachik National Park, and it's a National Historic Site and one of the first dark sky preserves here in Canada. Now, Kathy is Acadia First Nations, and so she was asked if she could share stories of the night sky and explain how to watch and how to look at the night sky. And she said, look, I'm happy to tell the stories. I can tell the stories of Moen and the 700 birds, as Moen, which most of us see as the Big Dipper or as the plow for those that are of European descent. As it moves through the sky, the story is being told of the bear rampaging through and scaring away prey. So the hunter birds chase the bear until they wound the bear, and the bear kind of sets right at sunset in a sea of blood until he licks his wounds, recovers, and then he comes back out. When he comes back out, again, he starts to scare away the prey. And it gives you the location of the Big Dipper at sunset throughout the year. Now, she said, I can tell this story because I learned this story from my ancestors, from my grandparents, and I can tell the story, but I don't know astronomy. I can't explain what you're looking at or how to use the Big Dipper to find anything else. So she reached out to the RASC Center, and Dave Chapman said, absolutely, I will come out with my telescopes. We will share views. And it started this connection between the First Nations there in Nova Scotia and the RASC Center. And specifically, Dave and Kathy realized that one of the great areas where they could collaborate is on the role of the moons in the Mi'kmaq culture. So the Mi'kmaq Moons Project tries to encapsulate the names of the moons and what they represent in terms of what's being seen in nature. So at the moment, we're at the waning moon. It's called the berry ripening moon because blueberries in the eastern coast are currently ripe and they're ready to be picked. The next one will be the mate calling moon. The one before was the birds shedding feathers moon because in the heart of summer, the birds shed their feathers to grow new ones to be prepared for the winter. So what moon you see is connected directly to what's happening in nature throughout the year. Now that's beautiful in and of itself, but it goes one step further. We know that the lunar month is around 29 and a half days. The year is 365 and a quarter days. So we fit more than 12 lunar months in any year. Many cultures have gone with the lunisolar calendar to try to capture this. What we talk about typically as settlers is the blue moon when there's 2 full moons in the same calendar month, and we leave it at that. But what the Mi'kmaq do is when a full moon cycle is starting, they look out to nature. If you don't see what's happening in nature as having changed from the previous full moon, you repeat the full moon. So it's organically taken into account this idea that you have a different number of lunar months in certain years. And it's just taken into account organically, and it actually works. It works beautifully when you go back over the years. When you see the number of moons and when the moons have been repeated, it really does kind of match that moment when you go from the 12 to the 13 months within that calendar year. So how do I do this with my students and with outreach events? Well, when we talk about outreach events, we talk to students and we talk to the public about the phase of the moon and when it rises and when it sets. And when I send my students out to do moon observations, I tell them that I want them to observe just with their naked eye or with the camera or even with binoculars, observe 2 phases of the moon, try to sketch out a little bit of what you see, and then look to nature to see what's happening in nature and does it match what you would expect from the Mohawk or the Algonquin interpretation of what the moon is. And it gets the students going out, it gets them looking at the moon, and then that doesn't leave them. They're doing that for years and years afterwards. I still have students who graduated in 2016, 2017, coming back out to our public events and talking about the moon as if they've never stopped looking. And I love that. And I love seeing them trying to capture some of the details. It's even gone to the point now where other outreach people are reaching out and asking for what all the different cultures call the moon and then incorporating that into their outreach. And so the University of Guelph Physics, my alma mater, has monthly stargazing guides where they bring in all the different variations of what the moon is called. And it's important to recognize that there is differences across North America from what the moon is called by these different First Nations. So I'll give you one example. The Cree Nation called the June moon the green corn moon to let you know not to pick the corn. But the following month, it's the corn is ready moon, because you can now pick the corn in tassels, it's ready to be picked, to be shared, and to be eaten. And so their whole agriculture, their whole preparation for winter is based on corn flour. And so knowing when the corn is ready to be picked and ready to be harvested is part of what they pass down from generation to generation. Now, I'm happy to say that I just got confirmation yesterday that the Mi'kmaq Moons book has now been put in for its final author's draft. It will be published in October of this year, and every single one of the moons has both the story of the moon as well as an artist's interpretation by one of the First Nations Mi'kmaq artists. And so you can see the connection and the development of this project over time. One of the great parts of this project was this actually getting one of the elders to capture the proper pronunciation, because each of these moons, the pronunciation, the words carry with it so much power in terms of the name of those moons. So some of these, they actually go into the story of why that word represents berry ripening. Some of them, they simply give you the actual interpretation in the words. But then there was another Mi'kmaq group called the Regeneration of Mi'kmaq Star Stories Through Storytelling, which is a 3-generational group. The grandmother tells the story in Mi'kmaq. The mom, Susan, retells the story in English, and her daughter actually goes through and acts out the stories. And those stories are all of these moon stories, plus all of the stories of the stars in the cosmos. So within the RASC, one of the things that we did is we took sets of star wheels representing the constellations of some of these different First Nations, and we created Native Skywatchers star wheels with the Native Skywatchers group. So this is the Dakota Lakota constellations. And so we're able to go out now and talk about the stories of some of these constellations and some of the moons. And we can specifically go through and talk about Moen and the 700 birds. And for that one, we can talk about it at different points of the year because it's a circumpolar constellation. You can see it all the time. So two-eyed seeing is kind of encompassing this entire approach, where we see from one eye the strengths of Indigenous knowledge and in the other eye the strengths of modern scientific knowledge, and try to combine those together into one interpretation. One of the favorite ones that I tell my students about is Wintermaker. Wintermaker is a larger constellation than Orion because it stretches all the way to Canis Minor and all the way out to Taurus. So it's much, much larger in scope. And the reason is because the Wintermaker brings the winter. Now, I have been doing astronomy for about 7 years actively. Since the start, one of the first things that I did is I recognized that when Orion passes above my neighbor's house, I better have my telescopes out of the garage so my wife can go and park her car. Because the snow's going to come anytime, and in the morning, my wife's car is the one that we use to drop the kids off at the bus stop for school when they were younger. So I would make sure that if I saw Wintermaker start to rise, when I went out for my evening walk, I would go and clear the garage that weekend. And it was almost instinctual. I just knew that, okay, I'm seeing Orion, I need to do this. Well, the Ojibwe have been doing this since the dawn of time. They see Wintermaker and they know it's time to prepare themselves for a very long winter. These stories are passed down from generation to generation. And so they can't just be about the observation of the sky. They have to combine in some moral, some ethical, some practical guides to how the community itself can work with nature so that the community can strive and can grow. Now, I would love to talk more about Orion specifically because I find that specific constellation is just incredible in every single culture. And in fact, one of the assignments that I give my students is I give them Betelgeuse in all different constellations from many different cultures, whether it's Western, whether it's Arabic, whether it's going down to the Dakota Lakota, whether it's looking at the Inuit, whether it's going all the way over to the Navajo. In each of those cultures, I show them what Betelgeuse is in those different cultures and how it's represented. And then I ask them to take another star and find it in a non-Western approach and give me their story. So this one student, Sophie Dillon, a couple of years ago, did this beautiful write-up on Sirius and how the flooding of the Nile was identified by the rising of Sirius. And so that's where Sirius was then representative of the goddess Sabtet, who was the one who brought agriculture and fertility to Egypt. Now, it would be wonderful to tell you about these 24 different variations of Orion, or of all these different interpretations of Sirius, the brightest star in our night sky. But we can't right now. And the reason we can't has to do a little bit with the respectful side of two-eyed seeing. At the start of COVID, NASA and the Native Skywatchers put together this set of beautiful webinars, and I got to attend and I got to talk to a few of the elders afterwards. And I'd even met a few elders here in Canada pre-COVID and talked to them a bit about the First Nation star stories. And what they talked to me about is really well encapsulated in the Navajo Diné educational philosophy. And this is something that's available from NASA for educators anywhere in the world. You can reach out and ask for a kit on teaching Navajo knowledge. But it comes with a caveat. And the caveat is that certain stories cannot be told at certain times of the year. So right now, we're in the heart of summer. I can talk about Milky Way stories. I can talk about meteor shower stories with the Perseids. I can talk about circumpolar stories any time of the year. But when it comes to the Winter Maker, when it comes to Orion, when it comes to the Slender Man, as the Navajo call him, you can't tell those stories until after the equinox. So the autumnal equinox marks the start of the time when those stories can be told, because that's when, not too late into the night, you see those stars rising. And so that representation, that respectfulness has to be in there when you share any of these stories. So what we try to do whenever possible in two-eyed seeing is to bring authentic voices to the floor. I am not an authentic voice for First Nation stories. I am not an authentic voice for Indigenous stories in Canada. I am an authentic voice for some Indian stories, for some East African stories, for even some settler stories. But I'm not an authentic voice for any of the others. So for any of the others, I have to reach out and get authenticity either through words shared with me or through those voices themselves. And that's a little bit harder to share on Zoom, but it is something that you can reach out and find, because a lot of this is now shared knowledge. And there's a lot of knowledge keepers that have been brought to the forefront to capture some of these stories in the way in which they're intended to be told. But it's also the case that certain stories are never recorded because they're not to be told unless those specific stars are in your line of sight when you're telling that story. And this is one of the things that the elders tried to impart into me, is the seriousness of capturing it that way. So I try my best not to tell any stories that are not supposed to be told, and to focus instead on the stories that can give light to two-eyed seeing while remaining respectful to the cultures that have created and shared and passed down those stories from generation to generation. Easiest way to do that is to look at the circumpolar constellations. Now, when I go out with my students or with an outreach event and we talk to people about the night sky, one of the first things we talk about is finding the North Star. So you use the Pointer Sisters, Dubé and Merak, and you point to Polaris. And yes, I call them the Pointer Sisters. And yes, that gets a lot of chagrin and a lot of shaking of heads from the other astronomers, but I love it. You know, Dubé and Merak, they're the Pointer Sisters. They're pointing to Polaris, and you can see over the span of the night the stars moving around Polaris. If you're really good and you go really north to where the sun never rises for part of the year, you can actually see this happening for the entire night, and the sun never rises. So you can see this movement all through the night. If you're very good with a camera, you can try to capture this in terms of a star trail, and a set of star trails gives you an idea of the motion of these stars around that North Star. And if you're very accurate, you can even show that the North Star itself is not at the exact north of our circumpolar sphere, but in fact, it's slightly off center, so it itself moves just a little bit. Now, why do we do that? Well, because once you identify the Big Dipper and you identify Polaris, you can star hop to so many different things. You know, arc to Arcturus is one of the first things I teach my students. I teach them about going across the diagonal to Gemini when I teach the course in the wintertime. I teach them about using Cassiopeia and Polaris in order to find the Andromeda Galaxy. And we use these markers, these flagpoles in the night sky in order to orient ourselves and find different objects that are objects of interest. But you can actually just pick the Big Bear. You can just look in that area, and there is so much wonder to be seen. I love showing students the Cigar Galaxy and talking to them about that supermassive active black hole in the center of that galaxy. And then I love showing them the Bode's Galaxy and talking about the fact that you can get that spiral nature of the arms visible. Or you have the Whirlpool Galaxy, and you can show them the cannibalism of one galaxy of eating up gas and dust and stars off of another. And then you can show them a planetary nebula and talk to them about the utter fate of our sun billions of years from now. And these are teachable moments where we teach our modern science and we bring in exactly what we're showing them with a target that's easy to identify in the northern sky. But we're not the first to identify the Big Dipper or to identify Ursa Major or Moen and the Seven Hunter Birds. This plow has been viewed by cultures all over the northern hemisphere. And as a result, there's stories from all of these cultures. So one of the questions that comes in is what observations are hidden in those stories. So I want to share with you a couple of them. And so first off, when we look at the pictures of the two bears, you get these beautiful renderings of, the big bear and the little bear, and the big bear's following around. The little bear's always oriented towards the big bear, but the big bear moves in circles around the little bear. And the Greek tales tell us of Zeus, Hera, Callisto, and Arcus. And Zeus and the nymph Callisto were really passionate, and Zeus had a bastard son, Arcus, and Arcus grew up to be a hunter. And then one day, Zeus and Callisto are having their little fling on a mountaintop, and Zeus hears Hera coming, so he turns Callisto into a bear so that Hera doesn't know that he's cheating on her yet again. So, of course, Hera comes, grabs Zeus, they go for a walk, and then behind, unbeknownst to Zeus, Arcus is hunting in those very same woods. And he comes across this bear, and he shoots an arrow, and he wounds the bear, and it cries out because the bear turns into his mother dying in his arms. And Zeus realizes what has happened, turns both of them into bears, and tosses them up into the sky so that they'll forever be safe, and Callisto won't die, and they'll be free from Hera's jealousy. Now that's the Greek story. And in some of the terms of the Greek story, Zeus actually picks them up by the tail and throws them up into the sky, which is why the tail of the bear is longer than the tail of a bear normally is. But the Roman version of it is very interesting because Jupiter and Juno, instead of Zeus and Hera, Jupiter and Callisto are together, and Juno is incredibly jealous. So Juno decides to turn Callisto into a bear, knowing that her son is hunting, so that her son can kill off his mom. And that's her revenge. But Jupiter intervenes, tosses them both up into the sky so that they're both safe from Juno. So what does Juno do? She goes to her friend Neptune, the god of the sea. And she says, do you see those two bears up there? They've wronged me. They're both dirty, and I don't want them ever to become clean. So don't let them touch the water. Don't let them go for a swim, which is why those two bears never set. They never fall below the horizon because Juno said her revenge was that they never get clean. So those stories encapsulate this idea of the circumpolar stars never setting, never falling below the horizon. And you catch a little bit of that as well in the European version of the wain and the Arthur's wain or the Odin's cart or chariot. It's this idea that it's a vessel for dead bodies, and the vessel for dead bodies happens closest to the horizon at sunset during the wintertime, because during the wintertime at sunset is when most of the people in the village would die because of the cold. And so that's when the wagon has to pick up the dead people, and in the summertime it drops them off, and then in the winter it's back down. Now, the Anishinaabe, the Ojibwe, the star people as they call themselves in their own language, they have a different term for this Moen and the Seven Hunter Birds or Big Dipper. They call it the Osher, the Oshek, the Fisher. And the Fisher is a beautiful story. And I'm going to tell you the story, but before I do, I just want you to understand that the Ojibwe refer to themselves as the star people because everything in their culture revolves around the night sky. Even their drum arbor circular dance is called Gajibigajig, which is the revolving sky in their name. And that circular dance is around the drum arbor, which is at the center, and that drum, the main drum, never moves. Every other drum slowly moves in circles around that main drum, and the dancers move in larger circles, just like star trails. So their story of Ochek is the fisher that brought summer back to Turtle Island, and Turtle Island is their name for Earth. It's where the humans are. So their story goes as this. In wintertime, Fisher was getting hungry, and so Fisher called together all of the animals of Turtle Island and said, look, we're all hungry. We're all really, really weak. Where is summer? Why is summer gone? And the other winter animals told Ochek that, look, the summer animals have taken summer back beyond the sky veil, and they've kept it in a cabin away from us. They're keeping summer to themselves. And Fisher realized that they won't survive without summer. So he said, let's go and get summer back. And all of the other winter animals were, we're too weak, we're too tired, we're too scared, we'll die. And so Ochek said, look, you create a diversion, I will go and get summer back for us. So all of the other winter animals created a diversion. The summer animals went towards the diversion, and Ochek took the last of his energy and ran in and grabbed summer off of the cabin wall. But as he did, the summer animals saw, and they started chasing Ochek as Ochek tried to come back to Turtle Island. And they shot Ochek, and they killed Ochek. And so Ochek dies, but as he dies, he drops summer onto the land, onto Turtle Island, so that summer comes back. And the creator saw this, and the creator said, I'm going to let you come back to life because of your sacrifice, and you will continue to do your sacrifice in honor of the birth of life that I'm giving you. And so this cycle repeats itself every single year. Now, that's a beautiful story. It tells us, why the position of the Big Dipper, of Ochek, changes throughout the year. That's nice. What else? Well, the fact that every single animal associated with the Big Dipper is typically either a bear or something like the fish, or something that can rise up on its hind legs, or something that can grab on with its forelegs and lean over, is why, it can have all these different positions in the night sky. So that's really cool too. But there's one more piece of information here. When you look at any of the artwork by the Ojibwe showing this specific tale, or from the other First Nations that have a similar tale about a fisher or a beaver or another animal that takes the place of Ochek in their story to bring summer back to us, the wound that they suffer when they go to steal summer back is always partway down the tail. And we know as observational astronomers or as beginners that that's a visible double star, Alcor and Mizar. It's visible to us, and it was visible to the First Nations. They could see that those are two different stars, but it's one point of light. So something must have split them. And that observation is captured within that story, where the tail is the only thing that's hit in every one of these stories about summer being brought back to Turtle Island. So that observation of a double star is hidden into those legends, but it's hidden in a way where it's always visible. When you look at the Big Dipper and you picture that story, you will see that double star. So in class, we talk double stars. We use them to measure the mass of stars. We do spectra of alberio to see that it's two different types of stars. And we even have a couple of members of the RASC who've done years-long studies of alberio to show the 7-year period of rotation around those two. The problem here is Alcor and Mizar are not a real double star. They're a visual double star. They're a visual binary. But in fact, one of them is itself a binary system, while the other one is simply much closer to us than visibly. It's just the lineup of them shows us an overlapping view, but if you look carefully, you can see two distinct stars. When I'm teaching ancient astronomy and I'm talking to students about the failures of the geocentric model, one of the big ones is, of course, retrograde motion. And so we look at retrograde motion using stellarium, and we see Mars moving back and forth around the night sky as it moves through. And you can see that at different points throughout the last few decades. And so the students get to explore retrograde motion a little bit. Well, it turns out that the First Nations have been viewing retrograde motion for a long time. but they have a very particular name for it. They call it Kitum Papinau, which is circles back. But the name that they share in stories is Muswahakak, the moose spirit. And the reason is that when a moose is grazing and something startles it, it won't stop and look around because it's already moving. It's already in motion, and a moose is incredibly large. So there's a lot of inertia. It really isn't practical for it to just stop and then start again. So what it does is it'll go in a huge circle. And if it sees what startled it, it'll react. But if it doesn't, then it just continues on its way. And so when they see Mars come back around, like in retrograde motion, they consider Mars as having been absorbed by the moose spirit. And so it's exhibiting that, and that's their observation, that every couple of years, they see Mars being possessed by the moose. And because I do this globally, I always have to have a picture of a moose because you don't know what a moose looks like unless you've seen it up close. I was unlucky enough once to be driving late at night in Alberta, which is over near the top of the Rockies in Canada. And I was driving up a mountain road and there was a moose sitting in the middle of the road. So I stopped my car, I flashed my lights a little bit, then I waited, and the moose just stared at me. And it took an hour and a half before the moose got up and walked away. But you can't really do anything because the moose is so gigantic and you're kind of scared to do anything like back up at nighttime on a mountain road. So I just waited. Now, this type of observation doesn't just go towards the large, bright objects that are easy to see in the night sky. There's even some incredible hidden science inside some of the observations from the First Nations. This is the Twinkling Stars song from the Meriam people of the Murray Island. So this is just north of Australia and New Zealand, just off the coast there. And they have this beautiful story, this beautiful song about a calm night when the stars are twinkling. And the point is why on Earth, if it's calm and cloud-free, would stars twinkle? And it turns out that what they're seeing is scintillation, but it's scintillation from upper atmosphere pockets of cold and warm air moving around, which happens right as monsoon season is starting. So when those high altitude trade winds are bringing the monsoon, even if it's clear, you see the stars above you twinkling. And so what the Meriam people recognized is that when that happens, when you see them twinkling like embers up in the sky, even though there's no clouds directly around you, the clouds are coming and it's time to prepare for monsoon season. And this is incredibly important for them because when it's not monsoon season, the only thing they can harvest, the only thing they can plant is yams, sweet potatoes. And you plant them in the earth, but if the monsoon hits before you harvest the yams will go moldy in that amount of water. So you have to harvest the yams and prepare for new plantings because monsoon season brings the green to the earth, which allows them to have more diversity of their actual sustenance. And this is just one example of many different examples, especially in Australia and New Zealand, where their stories match observations that connect to specific things in nature that they have to remember for survival. Now, for us, we capture this in seeing, right? Because even if it's not cloudy, even if it's transparent, if the seeing is bad, you know you're going to have a hard time looking at any objects at all, other than maybe the moon. Because everything else is going to wobble and move around and twinkle and go in and out of focus because that scintillation is so strong when the seeing is poor. So we have our sky chart, and every now and then our observational director, Alex Stefanescu, will call a no-go because the seeing is bad, and we all complain to him that, look, we just want to get out under the night sky. We don't care if the seeing is poor. We're not all going out to do astrophotography. While the astrophotographers are like, phew, I didn't have to pack up my equipment because that would have been a waste of time. So it really does depend on why you're going out under the night sky, how important seeing is to you. But for the Meriam people, it was a matter of life and death long term because they needed to change their actual plantings to survive for another year. Now, these observational moments of atmospheric phenomena are not alone to these, life and death type of situations, even interesting phenomena like halos, or something like a sundog, where the halo kind of coalesces into a second sun horizontally from your sun, maybe even a third one on the other side. These are now known to be created from hexagonal ice crystals at a high level of the clouds. And we now know where these 22-degree halos come from. At the time, though, there was no understanding of where they came from. So Aristotle even wrote about two mock suns rising with the sun and following it through the day until sunset, always to the side. In Newfoundland, when the first settlers came here, they talk about the winter of the three suns, because that entire winter, it was incredibly cold and incredibly icy, because those high ice crystals actually represent the fact that there's a lot of humidity in the air down below as well. And in the War of the Roses, Edward IV actually convinced his troops that the sun and the two sundogs were the three sons of the Duke of York that were coming with them into battle. They got absolutely destroyed, but he got them at least to enter the battle, which was, a difficult thing at that time because they were so outnumbered. And then you can look at the sun, and you can look at the sun's position throughout the year and recognize that there's so many archaeoastronomical sites that are built to represent the position of the sun at different moments. This is Stonehenge on the summer solstice, and it's pictures that many of you have seen before. And Stonehenge is one of those where we're not 100% sure exactly where all the rocks are set up, but we know that it is an ancient burial ground, and most burial grounds at that time were developed in such a way that one of the axes represented the position of the sun at the solstices. Now, some of you will remember that some years back, we found underwater stones in Lake Michigan. And there was a lot of questions as to whether this was the Michigan Stonehenge or whether this was, another one of these beautiful medicine wheels like we have out west. And it turned out that when they did a sonar of those stones, they were not in circular shape at all. There was a circular arc at a couple of points, but this ridge of stones was actually kind of more like almost an arrowhead style. And they were trying to figure out what this group of stones was. Now, here's where you can go to the First Nations and you can ask for their stories regarding stone structures. And that's what we did. We went to the Cree, and we went to the Mohawk, and we went to the Algonquin peoples, the Iroquois, the Sioux, and we asked them for stories about this. And it turned out that this was a Cree hunting ground. And what they would do is they would take herds of caribou, and they would actually move them through on one side of the rocks from the bottom there, while the hunters were at different breaks between the rocks to pick off the weak ones. And then at the very end, the caribou would be turned towards a new grazing ground. And so this was a way in which they would sustainably cull the herd, so to speak. And that's what the underwater stones were. There was nothing more there. In contrast, in Ireland, the Douth, Knowth, and Newgrange passage tombs are all very close by. And the Knowth and the Newgrange were really, really well excavated. The Douth, on the other hand, was one of the first ones to try to be excavated. And what they did is they blew off a bunch of dynamite to try to get in. And when they did, the entire thing collapsed. And you can see that collapse right there in the middle of the mound. But when they were able to pull out the entrance stone showed symbolism of what appears to be several solar eclipses captured through it. And in fact, if you look at the Knowth and the Newgrange passage tomb, you can also see inside them certain eclipses in certain positions. And the Newgrange, for example, lights up at winter solstice. At winter solstice, the sun, right at sunset, lights up the entire tomb straight down. More recently, they have found in some of the carvings, some of the petroglyphs inside both Newgrange and Knowth, they found what appeared to be solar eclipse boats. When you have an annular solar eclipse close to the horizon, and it gives you that boat shape like what the Egyptians used to see as the boat of Ra, bringing the sun back. That sketch has been seen in petroglyphs now in Newgrange as well as in Knowth. And one of our local members in Montreal, Robin Edgar, actually has written a couple of papers on this. One of my favorite archaeoastronomical sites that I talk to my students about is Chanquillo in Peru. And the reason I talk to them about Chanquillo is first off because the solar observatories are just fascinating to try to understand the architecture of them. But the easiest one to understand is looking from the solar observatory towards these dragon's teeth that are right before a mountain range. And if we look at those dragon's teeth, which are facing east, at sunrise, the sun moves from one end of the dragon's teeth all the way to the other from the sunrise observatory. So watching from the sunrise observatory, you can see in June solstice when the sun is at its lowest in Peru, to December solstice when the sun is at its highest, meaning in December solstice, the sun is the furthest south for them, and in June solstice, the sun is the furthest north for them. And right in the middle of the teeth, when you count equal numbers of teeth going in, you have the equinox right at the center. And this actually breaks up the 6 months into 13 identical sized pieces. So you have a 26-month calendar rather than a 12-month calendar, which actually makes it a little bit easier to fit in lunar cycles, but it's kind of weird at the same time. So there's a lot going on there. But one of the neat things you can do is this movement of sunrise is something that we can capture anywhere on Earth by doing a simple pinhole camera projection. So this was done using SolarCan, which is a group out of the UK. You can buy this little can with a pinhole on one side and photographic paper on the inside. And so I placed it at the top of one of my buildings facing south. And you can see from left to right, from sunrise to sunset. You can't see all through, unfortunately. I just did not have a wide enough angle. But what you can see is winter is this lowest part. And you can see that the sun rises to its lowest altitude, rises the furthest south, sets the furthest south. And then you have all the way through to summer solstice, June 2021, when you have the sun go all the way up there and then come all the way back down and set somewhere north of where we're looking at here. And in fact, here in Montreal at summer solstice, the sun sets at 303 degrees azimuth, right? So it really is north of west. This same behavior of the position of sun at local noon can easily be accommodated into these things called sky pillars. And the Mi'kmaq Moons Project, there's Dave Chapman right there. They put together this beautiful set of just concrete bricks. They just face north-south, and behind them, you can see steps that are placed, and that actually shows you from winter solstice, which is the furthest out, to summer solstice, which is the closest in, because the shadow of this pillar will be smallest at local noon at summer solstice and largest at winter solstice. So I have my students go out and do this. They can take sidereal trails to figure out the size of a day. They can use timeanddate.com, and they can chart out the altitude of the sun and figure out the size of a year. They can even calculate the tilt of the Earth's axis and the latitude from which they're observing by doing this type of graphing. And they see the difference between the sun at winter solstice, at equinox, at summer solstice, and vice versa. And then on the actual equinox, my students go out and they do the Eratosthenes experiment, where you catch the shadow. And the shadow at equinox should match the same angle as your latitude. And you can do this as simply as just taking a bathroom plunger and sticking it on the road. And that's enough to do this experiment and capture not just the size of the shadow, but also by doing that and figuring out the distance from where you are to the equator, you can figure out the circumference of the entire Earth. Now, this connects them a little bit to ancient astronomy and the way in which observations were done when things could be written down and passed on from generation to generation. Greek knowledge was passed to the Arabs. The Arab knowledge, a lot of it was burned, unfortunately, during the Crusades, but some of it survived. And then in Western Europe, we restarted the accumulation of a lot of that knowledge. And then you get knowledge coming over from India, from China, from Japan, from Australia, from South Africa, and you have these bastions of knowledge where there's not just literally people who can explain it, but also often things written down that can be then examined and translated. But then you have places like Chaco Canyon in New Mexico, where the people were completely obliterated. In fact, in the words of all of the local tribes other than those who lived in Chaco Canyon originally, those people were called the Anasazi, the enemy people. Now, we don't know if they were the ones who were aggressive, or if everybody else was aggressive and wanted Chaco Canyon. All we know is that every reference to them is as the enemy people. But when you look at the work that was done in Chaco Canyon, you have to wonder how advanced they were in their understanding of the night sky. This is a representation of the Crab Nebula. And this Crab Nebula is represented as having happened when Venus and the crescent moon were both visible. When you go back in time to around that time in 1054 AD, that's about where M1 would be in the night sky at sunset. And so that kind of matches what you'd expect to see. And on the floor underneath this exact sketch is a colorful representation of Halley's Comet, which would have passed right around the same time. And then you have this beautiful sun dagger. And now this sun dagger is incredible to understand. Unfortunately, because the area wasn't off limits when we first started to discover it, the rocks that created the sun dagger have shifted. And so now that entire area is off limits, but that sun dagger cannot reproduce itself exactly anymore. But the idea here is there's these sets of rocks and the sun shines in different positions at winter solstice, summer solstice, and at the equinoxes. So at the equinoxes, the sun falls just off center of this spiral. At the summer solstice, the sunlight right at local noon develops a dagger straight through the center of this spiral that then shrinks and falls down. And at winter solstice, the sun is low and it actually captures both sides of the spiral. But the equinoxes, there's a second dagger that appears in a tiny spiral off to the side. Now, this was just fascinating. You can actually see pictures of the summer solstice from when they first observed this taken at Fahadabute. But what's really interesting about this is that spiral itself, because it turns out that when you have the solstice, the full moon right around it will be in the opposite behavior. Let me explain. Our summer solstice, our sun is highest in altitude in the sky at local noon. The full moon at that time of the year is lowest in altitude because we are tilted towards the sun in the northern hemisphere, so the moon falls lowest. In wintertime, the moon is actually highest in altitude. And that's why a lot of the First Nations call the winter moon the spirit moon or the chief moon, because it's up really, really high towards the zenith. And it follows us all through the night, that really bright full moon. So what's incredible about this is that placement of the moon means that the moon would give you the opposite solstice behavior, right? So the summer solstice moon would give you the two full moon daggers on either side, but the winter solstice moon would give you the dagger right in the middle. But we know that the moon's orbit with the sun and the earth has a 5-degree tilt, so there's a precession to it, which is why the timing of our supermoons, if you want to use that term, changes throughout the decades. Well, it turns out that over that 18-month cycle of that progression of the 5-degree orbit, you go through that entire spiral from one side to another. So that spiral encompasses the movement of the moon with respect to the sun at solstice behavior. Now that takes a lot to be able to sketch that much in to simple observations by a group of people that we know nothing about. And then you examine some of the other petroglyphs and you identify what appears to be a really active coronal full eclipse. And you look at that exact same coronal full eclipse from another petroglyph from another area of the US, and you see the same type of curly coronal behavior represented. And if we follow the solar maxima back to the total solar eclipse that would have been right around the time Halley's Comet passed above Chaco Canyon, it was a solar maximum. So we would have seen incredible amounts of coronal behavior and looping. So I'm really excited for April 8th, 2024, when we're going to be at solar max and we're going to see a total solar eclipse, because I want to see how close to any of these observations we'll actually get to see. But it's summertime. And summertime, when we go out, we love to see the Milky Way, and we love to see a certain phenomena that some of us have managed to see, which is just a few Perseids, just a few of those meteors. Of course, there's satellite trails as well. Those will come through. But getting a chance to spend some time under the night sky and see some Perseids, enjoy the arm of the Milky Way, that's just it reinvigorates us and it connects us a bit to this idea that we're really seeing all the way through our galaxy. And then when we see some of the deep sky objects, we're seeing beyond our galaxy. So let's talk a bit about the Perseids, because I love some of the legends of the Perseids, but they sound somewhat silly. They sound somewhat fanciful, right? So Coyote Dances with the Stars was the legend that I mentioned, the Hoopa legend that I talked about in the Global Star Party right around the heart of the Perseids. And the legend goes like this. Coyote was lying there watching the stars twinkle, and he thought that they looked like girls. And they looked like girls dancing. So he thought, I want to go visit those girls. So he asked the tree, "Excuse me, Redwood, would you help me get up to the sky? I want to see the girls." And so the Redwood offered to bend over and launch the coyote up into the sky, but he wouldn't be able to get the coyote far enough. So the coyote asked Spider, and Spider said that Spider would create a very long web for Coyote to catch and climb up. So plan was made. Coyote jumped onto the Redwood. Redwood fired him up into the sky, caught onto the web, climbed up, and he found the girls. And indeed, they were dancing. And he said, "I want to dance with you. I'm strong. I'm fast. Let me dance with you." And the stars, the girls, they said, "You can't dance with us. There's no way you can keep up. You're just a piddly little coyote." And so the coyote got a little offended and said, "I can keep up with you. Don't worry, I can." They said, "Look, if you start to dance with us, you have to understand, we don't stop dancing. We are always dancing." So Coyote said, "I can do that." So he started dancing with them, and they had such a beautiful beat, and he danced, and he changed partners. And after a full night, he got tired, and he got a little hungry, and he got a little thirsty, and he said, "Do you mind if we just stop so I can grab a drink?" And they said, "We don't stop. We told you that. You have to keep dancing with us." So he bucked up and he kept dancing with them, but he started to get tired, and they had to kind of drag him to keep him with them. And he just kept getting more tired. He said, "Can we please stop so I can have something to eat? I haven't eaten since we started dancing." And the girl said, "We don't stop. You have to keep up with us because you said you'd dance with us." And so Coyote tried, and they dragged him, but he just couldn't do it. And he fell lower and lower to the earth, and then he fell to the earth. And as he falls to the earth, that's the meteor that we see. So for every coyote that tries to dance with the girls, as they fall back to earth, we see these beautiful shooting stars. It's a lovely story. Where's the two-eyed seeing? Where's the acknowledgement there that there's something that they've identified? Because other than the fact that all the shooting stars seem to come from the same radiant place, and that's where all the girls are dancing, it's hard to see. And then I came across this beautiful reference from the Ojibwe, and the Ojibwe called the Wolverine the one who came from the shooting star, Gwingawaagi. And the reason is the first time the Ojibwe ever came across a wolverine animal, it was drinking from the water in a crater. And so as they approached the crater, this animal they've never seen before raised its head and snarled at them. And so they thought that it had come from the shooting star that had created this crater and filled it with water, and that the wolverine had just come out of the water. And so that was what they associated to it. And so then you start to wonder if the coyote are often found grazing or really just drinking from these small, pristine lakes that are created when a crater actually hits the ground. And so I don't know, but this is the supposition based on what I've talked to one Ojibwe elder about for this legend of the Wolverine. And he said that a lot of animals are given names associated with where they're first found. And so wherever they're first found, that associates. But the problem is a lot of First Nations give coyotes a very mischievous nature, including some that talk about the coyote starting that Milky Way arm by grabbing the bag of stars from he who would put the stars in the sky and racing off with it, but the bag was open, so it trailed off a bunch of stars behind him. Now, whenever we look at these beautiful pictures, and I've taken this one from Adrian, our own University Lowbrow's member. He does these beautiful nightscapes, and he had this wonderful picture of the Milky Way in the early morning, early on in the spring. And then another friend of mine, Andrea Urones from the Rask, Ottawa, had this wonderful picture of the Milky Way late at night, just over top of the Rideau Canal and the river there in Ottawa. And we see these beautiful rivers, and we wonder, where did these rivers of stars come from? And the Australians have their myth with Pre-Perigi, and Pre-Perigi was a renowned warrior who really knew all the tricks to catch prey for his tribe. And he also knew all the songs, and he knew all the stories, and he played all the music. And so the whole tribe was really dependent on him. But he got bored. And so one night while everybody else was asleep, he decided to go and hunt for a flying bat. And a flying bat was what was a delicacy. And so he found this entire tree full of them, and he decided to kill the chief because it was the largest one. It would give him the most succulents. So he shot it, and it screeched out in pain as it died. And all of the other flying bats woke up, realized what had happened, and they grabbed Pre-Perigi and took him up into the sky. So the tribe woke up, and there was no Pre-Perigi, so they couldn't remember how to hunt, they couldn't remember how to dance, and they just kind of mulled around. But late that night, they saw all the stars line up in one of their ancient dances, and they heard music coming from the heavens, and they realized that Pre-Perigi is now in the heavens making the stars, the flying bats, dance to his tune. The Greek myth that we're taught in school is that of Heracles, suckling at Hera's breast when Hera doesn't know. And so when Hera wakes up and realizes that Zeus's bastard is suckling at her breast, she tosses him away. And as he's disengaged from her teat, the milk goes flying, and that flying milk creates the Milky Way. And that's where Eratosthenes gave it the name, the Circle of Milk. And this beautiful painting representing the origin of the Milky Way is at the National Gallery in London at the moment. The Romans had a myth where it's actually two halves of the heavens that were either pushed together or torn apart by scorched sky. And that scorched sky represented a line to the abode of the souls of heroes. And in fact, the Arab astronomers went a step further and said that that's actually the cart track that carries the souls themselves. And the argument was made that the Milky Way itself was beyond the stars that we see in the celestial sphere, the ones that the constellations are made from. And so the idea that the Milky Way is something deeper and something further was something that was tried to be captured by the ancient astronomers. But when we look back at the First Nations stories, they're often of mischievous. I told you about the coyote. The South African sky is considered to be created by a mischievous Kosian girl who was asked by her mom to go to bed, and she got angry and kicked at the fires. And as she kicked at the fires, the embers popped up into the sky, creating the heavens. And a lot of these First Nations stories of African descent are really interesting because the twin children, or the Maulisa, or in that case, the Nanabaluku, they are the supreme being and the creator of the universe, but the ones who control what we see on Earth are often back and forth in terms of gender. And when you go back through the stories of a lot of these First Nations and a lot of ancient astronomy in Europe, gender is very fluid there. And that's something that they really hold on to, is this idea that a man and a woman, or a woman and a man, is something that depends on your perspective on their action. One of my favorite legends is the Makayosokia legend, which is the Blackfoot legend of the wolves who come in the springtime. And in the springtime, we have no need for them. So in the springtime, they just take off into the sky, going back to the sky world. But come winter, we suffer. And as we suffer, the early humans didn't know how to search for food. They didn't know how to create food that could be stored, that could sustain them over a heavy winter. And they didn't know how to shelter for themselves. So one snowy winter, the wolves came down and found the family, and they showed the young man how to bring fresh meat, showed them how to camp, showed them how to bring different animals together to help them, how to cooperate with the animals, which buffaloes to hunt and which ones not to, which ones to eat and which ones to be left alone. And then come spring, when the village had survived, they would move off into the sky as the wolf trail. And that's your arm of the Milky Way. It's the wolf trail. And that's why the arm of the Milky Way changes its angle over the span of the year. It's because the wolves leave us when we don't need them and come back when we need their help. And then there's the Chinese mythology. And this was the one that I'm going to end on tonight because this is the one that's most recent to us, because the mythology has to do with two of the three stars from the summer triangle. Vega is the Weaver Girl. That's the brightest star up at the zenith of our summer sky. And then Altair is the cowherd. And Vega and Altair fell in love, and they had a family. They had 2 kids. But the emperor had never sanctioned their love. So the emperor got angry, and he separated them, and he banished them to opposite sides of the river, the harmony of the heavens, the Milky Way. And so now you have the Weaver Girl alone, and the cowherd left to raise their 2 boys. And every summer, on the 7th night of the 7th lunar month, the magpies create a bridge that brings them together for one night till sunrise so that they can still be a family. Now, this mythology was beautiful. I loved it. It had this nice poetry to it. There's even this beautiful animated opera that I show my students. But one thing that always got me was this 7th night of the 7th lunar month. And we just passed it. That was the first quarter moon at the start of August. If you think about when you go out for the first quarter moon, for the 7th lunar month, you see the arm of the Milky Way rising fairly high up towards the zenith. And so once that first quarter moon is up there, as the sun sets, you can't see quite as much detail. And it's really high up, so the shine of that first quarter moon actually does appear to create a bridge through. And it's only at that point, after that, the moon is too bright. And it's so bright that it actually overwhelms the arm of the Milky Way. And you don't see that beautiful galactic arm and the stars and the darkness in the actual dust that you can see in that view. And before it's a quarter moon, it's too far away from that river. It's farther away, closer to the actual horizon. And so you don't see that same effect. So really, that observation is particular to that 7th night, that first quarter moon, when you're in that 7th lunar month, when it's really high up. And it's important to recognize that the Chinese, it's a lunar solar calendar. So that 7th moon moves around somewhere between mid-July to late August, early September. But it's always right around that time when the arm of the Milky Way is at its highest for us at sunset. So when you go out over the next few nights and you see the arm of the Milky Way, or you decide to go look at the planets, or you decide to see a few shooting stars or watch a satellite move through, try to remember that we're not the first to see any of this. And as we picture the constellations that we're used to, the Sagittarius teapot, the Scorpius hook, when we see the Big Dipper, when we see Cassiopeia and the Queen sitting there waiting for the tea to rise out from this wonderful kettle, tea spout, come all the way down across to Cassiopeia where the Queen is waiting for her cup of tea. Remember that we are sharing the night sky, not just with ourselves, but with these other beautiful, beautiful cultures that have been seeing this since the dawn of time. And so I want to thank you, Lowbrows, for the two-eyed seeing reception and for hopefully moving forward using both eyes for the benefit of all. And I want to just give you one last example. And this is an example that came up this year. This is a picture that I've used for these two-eyed seeing talks for a while for my thank you. And it's this beautiful Haida Gawai auroral eagle with a full moon. And somebody asked me back in March, they said, really, if you have a full moon, you can't, there's not much aurora to be seen. I mean, there's no way that this is a real representation. This is clearly just a fictional painting. I mean, doesn't this just kind of undercut the reality? These are just stories. These are just legends. These are just for fun for us to listen to. And so from January in Lapland, Finland, here is a picture of a full auroral wing and bird with a full moon there right beside. And so with that, in the words of the Mi'kmaq, I will say Walaliok, which is thank you, and I'll open it up for questions.
Thank you, Karim.
Yeah, thank you.
My pleasure.
Karim, I was wondering, has anyone ever tried making, I guess, the equivalent of a genealogical chart among the nations, as either how their myths both relate or differ from each other, or even their astronomical techniques?
So we are working on that right now in terms of the myths. The RASC is doing this wonderful initiative. Let me just see if I can share it. It's called the World Asterisms Project, and we're trying to go through, and we've talked to a bunch of these different cultures. This is being led by our current president, Charles Ennis. And what we're trying to do is we're trying to identify not just the stories, but also when these stories were first either recorded or when they're handed down. It's hard to tell when they started. But if we can find specific connections, so for example, the Fisher that I talked about, it's not just the Ojibwe that have that reference to the Fisher, the Cree have it as well, as do the Sioux, but to a different animal than the Fisher. But they have the same type of tale of some animal bringing summer back and being shot in that tale. But it's a slightly different variation of the story for each of them. But they the Cree and the Ojibwe, for example, both refer to Earth as Turtle Island. And that Turtle Island seems to be kind of synonymous with a lot of the First Nations here in North America. So that definitely seems to have crossed back and forth from side to side. There's also an interesting, for those of you who are interested in learning some of these constellations and asterisms, the Astronomical League has a certificate for identifying and observing the different asterisms of different cultures. So that's something that you can actually explore. And Stellarium, if you download it on your computer, you can turn on different cultures and see the way in which the night sky is viewed by them.
Thank you very much.
It only partly answered your question. The other side of it, it's just so hard to target where a legend started because they were all word of mouth initially.
What about astronomical techniques and the type of observatories that they were using?
So the astrolabes, the armillary spheres leading to the sextant, leading to the celestial sphere representation, all of that is fairly well established in terms of the hierarchy or the order in which some of those instruments were created.
Well, I was thinking more of like some of the these more monolithic type things like a Chaco Canyon.
Right. So the archaeoastronomical ones, that's where it's hard to identify which ones were for observational purposes and which ones were created that way because that was part of the way in which the culture did. So Stonehenge, for example, there's other henges near it that are much easier to interpret than Stonehenge, but Stonehenge is more well known because it was where a lot of Druidic festivals were held, right, in the middle century. So I don't know that there's a cataloging of the age of all of them. I do know that the medicine wheel in Alberta and the one in Wisconsin are actually considered to be older than Stonehenge. And so those medicine wheels are set up along the solstice line. And you can identify specific stars as they would have appeared 1,000+ years to actually one of those is 6,000 years ago. Because of the precession, the actual order of the stars has changed for us in terms of where one rises and when it rises. But if you move backwards in time 6,000 years, it matches fairly well to what we can see with, I believe, the one in Wisconsin. And that's where, of course, you have the chimneys of the Great Pyramids facing where Tubin would have been at the time, which would have been our North Star. So I don't know exactly the hierarchy in sequential order, but I know that there's a lot of error bars on the age of a lot of these.
Thank you again.
My pleasure.
More questions for Karim? Okay, maybe that was it.
Awesome.
All right. Once again, thank you very much.
Thanks.
I'll never look at the night sky again the same way, Karim. So with that, we would like to bestow upon you a little token of our appreciation by giving you a club t-shirt or baseball style hat. What would you prefer?
I think a t-shirt would be fantastic. Thank you.
Cool. What size?
XL?
Okay. If you can just email me a shipping address, we will get that on the way to you.
Sure. Thank you so much. That's wonderful.
Thank you. Okay, with that, we are going to bring up Austin, is it Edmister? Edmister? Okay, who is Assistant Director of the Detroit Observatory. And we're going to get him hooked up here for our second presentation.
Logged into Zoom on here, so I can share.
Oh,
screen.
there you go. There you go.
I should.
So-
I'm audio in the room then.
I think, oh, no, you're probably going to need
Oh,
this.
Probably good.
Mhm. And before you get started, Austin, can you tell us a little bit about how you became Assistant Director at the DO?
that's in my talk. Got it right
Oh,
there at the beginning, yeah. Siri. Not walk away. Hello. So let me share my screen. Play. I'm assuming everybody can see. Where everybody's seeing my presenter view. I don't want to do that. There you go. Okay. All right. So thank you so much, Charlie, for having me out here. Thank you to those in the chat that helped me find my way in here. I'm still kind of, I started last year, but I'm still kind of new to campus. So I kind of forget that some places have different accesses at different times of day. I need to start trying my identification card on buildings to see where I can get in.
Changes up throughout the year.
Yes, yeah. So my name is Austin Edmister. I am the Assistant Director for Astronomy at the Judy and Stanley Frankel Detroit Observatory at the University of Michigan, Ann Arbor. I just recently learned that's actually our official full name. That's the full name of the observatory now. But we like to go by the Detroit Observatory. That's how you know us. We've kind of been the University of Michigan Observatory at certain periods. Originally, we're the Detroit Observatory. Just due to the Detroit donors that helped fund the observatory. I'm not going to do too much of a history lesson on the observatory. I'm going to kind of talk about the facility in general. Many of you, I think, were involved with the observatory in the past, probably worked with the telescopes. You might know them better than I do. And I'll tell you a little bit about our new facility, things we can offer with that new facility, and some of the programming that we're doing right now, and some of our plans for the future. So just a little bit of an intro for me, my story. I started at the University of Illinois in 2012. I studied physics and astronomy, and I was also very involved with the Astronomical Society. You can actually see me in this bottom right picture. That is me in the black shirt talking to the guy in the orange shirt. That is the Venus 2012 transit. So I was very lucky. That was like my first year. And I was about 1.5 years into astronomy at that point, and we had this. And I got to help point one of the Dobbs with a solar filter on it for the Venus transit. We had a big wall of clouds just threaten us the whole way, and we got to see the whole thing. So that was really awesome. And it was a very engaging experience for me. That's probably helped keep me on a path for a long time. I went to graduate school, got my MS in astrophysics at Michigan State University, 2015 to 2017. And I also helped with public programming at the MSU Observatory there. And often I kind of enjoyed finding myself outside with the with one of their celestrons, kind of pointing people to different parts of the sky. And then in 2018, I started at the Ella Sharp Museum at the Hearst Planetarium in Jackson, Michigan, if you've ever been there. It's a wonderful little planetarium, beautiful museum. sort of a 19th century farmhouse that kind of grew an art gallery and a planetarium in the 60s. And they got a new digital system back in 2014. So I got to help start up their public programming, which they kind of stalled after a change of staff a couple of times. And then in 2021, last year, I started at the Detroit Observatory as the assistant director for astronomy. And the Detroit Observatory has undergone some changes, which we'll talk about. And I've been there to kind of help things along with the astronomy programming. So that's me talking to a group we had just like 2 weeks ago. I develop and facilitate all the astronomy programs at the observatory, anything that's related to the telescopes, anything that's related to the astronomy content or history. I try to lead and help out with. I run all the telescope operation and training with our student docents, and I supervise all the astronomy student docents, and I supervise our history student docents when they are doing things related to the telescopes or the scientists or astronomy. And I also help with all the public outreach. Much longer list for my job responsibilities, but anything space-based at the Detroit Observatory is usually my game. And this is the observatory itself, a beautiful picture that was taken near our opening in April. And here you can see the biggest change, right? There's now a very sort of long, low-level building at street level facing Observatory Street. Our address is still Ann Street, although we're kind of looking to get it changed to Observatory Street because that would seem appropriate. But this new building has a lot of purpose with it, right? They didn't, you could almost argue like, hey, a $10 million building attached to your old observatory kind of helps preserve its status for the next like 50, 60 years. Maybe they won't want to put a parking lot there. But at the same time, it's also given us a lot of new ways to actually access the original building. Many of you probably remember the steep ramp and very steep stairs that went up to the old building. And now we have this street level new building with some amenities that help us get into the observatory a little more cleanly and allow a sort of front gate access to the observatory from the street. One of the big additions is this classroom. This classroom can seat different amounts of people depending on how you style it, much like this room. It's a little bit bigger than this, I think, long ways. And we have a seating capacity of about 75 people lecture style and about 45 people discussion style. So we have tables, we can reconfigure them for different classroom settings. We can clear everything out. We had a retirement reception just last week from the urology department, and we can fit 45, 50 people in there that way. So we really lean into the room's flexibility for offering different things like talks. We can do presentations. We can do more passive presentations, like with students, and we can host private events. And so we've done all of those so far. We've had classes come through for discussion sessions and labs. It's been really great, very useful classroom, a lot of very advanced technology with video capture and audio. And I'm not much of an AV person, so I'm still learning a lot of that myself. And before and after that classroom, on our left, we have our new lobby. So you can see a little bit of a sitting space. And that large wall that kind of looks like a poster is a screen. That LED screen, like many of the screens in the new edition, connect together in the building on a single network. So we're able to share videos, images very easily. We're able to share presentations. We can quickly throw up a welcome screen. If you guys ever show up there, we'll probably say, hey, welcome Lowbrow astronomers back to the Detroit Observatory. And it's been really cool. And there's sound throughout the building and everything like that. And then behind the classroom, further down, so you can actually see the classroom to the right of this large stair, and just left of the large classroom is this large stairway taking you directly up to the main floor of the original observatory. And then there's a bathroom under that. And on that brick wall to the left is an elevator. And to the left of that is a catering kitchen. So that kind of gives us a little more accessibility to the main floor of the observatory, and allows us more options with private events that want to host some sort of larger ability to serve food or things like that. And then the telescopes itself, many of you are probably familiar with these telescopes. They're working back in action. They've been doing great since we've started. The FITS, we use it to observe every one of our Friday night events when there aren't any clouds, and we've had a heck of a summer for clouds on Fridays. I think of the few dozen of nights we've had, I think we've had about 5 or 6 of those as actual like clear nights for Friday. and then a couple that were just so humid we didn't want to open up the telescope. And then the Meridian Circle is doing good. We still have probably like 15% of the telescope that needs to be finished restoring, the microscopes to look at the setting circles, those large gold wheels or brass wheels, and a few of the extra things to help align and set the telescope need to be restored. So those will be hopefully happening in the next year or so. We can look through the telescope, but you can't see the spider lines at night without the illumination and little things like that. But we love using them. The people have had a really great time. And like I said, you know, the purpose of this new addition that we see is to get more people in there. So as opposed to historically, you know, maybe smaller, more contained groups of people, we now have a continuous flow of public programs and tours at least once or twice a week of people coming through. And so I think now for just public programs alone, we've served over 1,200 people in the past 5 months. And we want to expand on that. We want to do more public programs. I'll mention a little bit about that later. And we're also opening up to private events and classes. We've had about 200 or 300 students come through. That's a wide range of number, but around that range of students come through for classes. Many of those students became our student docents. They were very enamored with the building and they wanted to get engaged with it. And stuff like that. We're, you know, hoping to sort of reestablish our relationship with the Lowbrows, with the Student Astronomical Society, and then with the university as a whole. We want the whole observatory to be a resource and a teaching facility for the whole university. So we kind of focus on reaching staff, we kind of focus on departments, local organizations like this, the Ann Arbor community, and so on. We do this in a few ways. We have astronomy nights. They're not observing in this particular image, but we try to use the telescope as much as possible. And whenever we have a tour at the observatory or a private event, we try to set up either tours through the building of the telescopes or telescope observing, nighttime observing, and now solar observing. We have a solar filter for the telescope. We're going to be starting astronomy days where we have open hours during certain days of the week, every week. And we'll have solar observing running through those daytime hours with either, we have white light filters and eventually we'll have some H-alpha filters. We're looking at some Lunt telescopes. And then we have seen in depth. You can see one of our student docents talking to the family next to a large cutout of Franz Brunoff. These seen in depths are kind of the direction we want to go. Our astronomy nights are something that happen every week. And we like showing as many people as possible the observatory, as many people as we're capable of showing in a night. You know, we're only a staff of 10, and on a given night, there's 5 or 6 of us. And so, 100 people all in one group, you've probably experienced this. It can be kind of overwhelming, logistically getting people through, and also having all of those people get to engage with the telescopes, get to engage with the observing, to get to look at Jupiter or Saturn or a star cluster for longer than, one look and then moving on for the next person in line. So these seen in depth programs are going to be kind of designed around smaller groups of people that are much more focused. So you might have 25 to 40 people visit for one night instead of 100, and they get that whole night sort of more to themselves. And so they're, we build presentations around a specific astronomer or a specific type of astronomy, something that's more specific to the Detroit Observatory itself. In this particular night, we talk about Franz Brunoff, or we've talked about James Watson, the second director. We are building nights in the future to talk about the telescope maker of the Fitz, Henry Fitz. We want to talk about many of the women and minority astronomers that have worked at the University of Michigan and the Detroit Observatory and kind of tell their stories. We want to talk about solar observing. Solar astronomy is very important to the University of Michigan with the McMath-Hubert Observatory. And, we have the climate and space sciences here that are involved with solar physics. And so these seen in depths, we think is going to be the way we go. In the future, whether it be a Friday night or something on the weekend, we're still exploring that. But astronomy nights are our main thing now. They will kind of phase into being once or twice a month on a weekend. And these seen in depth tours will become our primary tour for evenings. And as we build up more of these scene and depth tours, they will kind of filter into rotation. So right now we only have 2 or 3, and soon we'll have 15 of them, and that will become our main tour. We also host science talks. I gave one of them. We have movie nights. We saw A Trip to the Moon, and we had a speaker from like a film history professor here at the university talk about A Trip to the Moon. He showed us a special printing of the movie that shows like the extra 10 minutes that you don't see on YouTube, and got to talk about it and then observe the moon. It was a nice clear night, and we got to look at the moon. We want to host Bentley nights. As you might know, the Detroit Observatory now belongs to the Bentley Historical Library, and it was originally imagined as sort of a 3D archive space, but at the same time, it is its own space. And so while being our own thing, we still want to act as a gateway to the Bentley and its many amazing resources and archives. And so we will host them once a month with a speaker or items that they will kind of show off and talk about, books and stuff like that. We have occasional one-off programs. One of our docents, in fact, it's the one in this picture right here, Ava, has an idea for a 70s night, these little special nights where we might have people dress up from the 1970s and the 1870s to come to the observatory and explore, the 1870s history of the observatory, while also learning about the 1970s history of the 37.5-inch being demolished, or that observatory being demolished and stuff like that. So little fun things like that we're exploring. Private events, of course, we've had a few private events, from retirements to we had astronomy commencement there, and they all want to come back, so we've had really good luck with that. And even if you guys want to have like special meetings there, our pricing for that right now is free, and then we're looking in the future for private events to be mostly just a recharge rate. So how much does it cost us to run the observatory for 2 to 3 hours while a private event is there? That $50 to $70 will be our rental rate or our recharge rate. And then outreach, there's always things happening around campus. And for me, the biggest way to get people to come to you is to go to them. And so we want to sort of build out our telescope ability through reflectors and refractors that we can transport across campus pretty easy into downtown and be present in the community and sort of invite people back and engage people that way. A lot of stuff. And again, this is a pretty broad sweep of our programs, but we're really excited about them. We're really proud of them. And I do want to mention, student docents are kind of our main thing right now. Some of you might be curious about volunteering at the observatory. We haven't really focused on that too much because we're kind of focusing on this being very much about the student docents. So I help write some of the programming. Gary Krenz, our observatory director, helps develop programming. But then the people you see, you interact with, we want that to be the students to sort of make it, it's a university facility, and we want the students and the visitors to kind of feel that connection of them working there. But we are exploring in the future, once we have a better established our student docent system and staffing levels, we are then going to start looking for holes, places where it's like, oh, it'd be nice to have a more seasoned astronomer expert here to help us. Be nice to have some volunteers and places like that. So that's still growing with our programs, but we'll keep you updated. And then one of the side fun things is we've been working on telescope imaging with the FITS refractor. We have a little CMOS camera that we can attach to the FITS. And we've been practicing taking pictures across a broad spectrum of things, pun intended. On the top left, it's a very rough image. We were kind of still getting used to the tracking of the telescope, so we couldn't take a lot of images, and we were still learning the actual software itself. But in the top left, you can see a little white spot circled, and then in the next image, it's gone. That is the asteroid 79 Eurynomy, the first asteroid discovered at the Detroit Observatory by James Watson. Now, unfortunately, that asteroid happens to be in its orbit where it was a 13.5 magnitude, which with light pollution is exactly the seeing limit of our telescope right now. So we were only able to image it, and we had a time learning how to get that pointed and tracking well enough to do that. On the bottom, this was yesterday's sunspot, region 3078, that Riley and I were able to capture. On the bottom right, it's a piece of Messier 10, And then on the top right, you can actually see the brighter cluster piece of the Eagle Nebula. And in the bottom left of this image, you might actually see the pillars of creation faintly starting to come out. So, not the most amazing astrophotography, but we're learning and we're picking up pretty quickly. And so I'm excited to see where that goes in the future. We're going to try to get some good images. And one of my dream goals is to build an image catalog of most, if not all, of the asteroids discovered by James Watson that we can share with people. Because as you all know, Michigan can be a very cloudy place. And so we want to be able to share things with people and still talk about the observatory and the telescope visually when we can actually see through it. And then, we want to collaborate with you. We do all these things, but we want to do them with people too. We want to engage with the community. That's part of my job, is to more and more reach out with these established groups in the community and collaborate with you guys with talks and presentations. You guys, I'm sure across your membership, have a lot of really talented experts, good astronomers that can teach us things and have unique experiences, anecdotes to tell us about. Be present at astronomy nights. Now, I know our Fridays kind of conflict with your Fridays. Our astronomy nights, like I said, may eventually move to be a weekend thing. But at the same time, we do have astronomy nights when you don't have meetings. And so maybe that means like you have a couple of people there in that multi-purpose classroom at a table with a setup that you'd like to do, or you're helping us observe as a volunteer. Of course, meetings in meeting space, if we can figure something out with that. Doing star parties would be really fun, and collaborating on outreach projects. This is a really short list. I'm sure we can meet in the future and talk more in depth about this. But I'm really excited to be here, and I would like to get to know this club and get to know what you guys want to do and what you think. So sorry, that was kind of a short presentation, but
Yeah, Austin,
yeah.
have you guys thought of giving an acid test to a light pollution filter?
So the filters that we use on our cameras, supposedly it's RGB and it's split right where the light pollution is. But maybe in the future we can look into new filters.
Just a question. You've got an extreme example of why they should be effective.
Really? I mean, astrophotography is not my expertise. So in this, are you referencing something in this picture?
No, just the general scene where you're at up there with all the lights.
Yeah, Ann Arbor in general is pretty tough.
And the hill with the medical center right there.
Yeah. Fortunately, all the good stuff, usually, I mean, there's lots of really beautiful things in the northern sky, but a lot of really amazing things. And a lot of my favorite things are in the southern sky, where it's kind of pointed away from Ann Arbor a little more. So that's been very fortunate for us. Although if you go below like about 20 degrees, which that's already awkward for the telescope, you can't see anything.
Yeah. Thank you.
Yeah, thank you.
Any other questions? Well, then I have one.
Sure, yeah.
Can we start our collaboration by offering you a hat or t-shirt?
Oh my gosh, I'll take a t-shirt. Yeah.
Okay,
Yeah.
what size?
I'll take a medium.
Okay.
Thank
And
you.
if you could just send me a shipping address then.
Oh, for sure.
Okay. Much appreciated.
Yeah, thank you.
Hopefully this is the beginning.
Yes, definitely. I know you guys have had a really important part in the observatory's history, so I'm sorry it's taken so long. It's been a really hectic year, but it's about time. So
Yeah, that used to be our regular meeting place many years
yes,
ago.
yeah, in the library, I believe.
I think that's what I heard.
Yeah.
Something like that. Probably you remember that, Tom. It was a little bit before my time. Just a little bit before.
So right now the library, from what I understand, this is sort of out of my domain into the exhibit and history portion. It sounds like the library is going to move towards being a sort of flexible exhibit space. Now, what that means with respect to clearing it out and having small meetings in there, I'm not sure. But then also, there's no longer, it looks like there used to be a projector screen on the south wall by the window. Maybe, I'm not sure how you guys met in there, but as we change dates and stuff, I know you guys have Friday night meetings, but if we can figure something out in the future to have you guys back at the observatory meeting.
That'd be
yeah.
cool.
Yeah,
So-
Jerry Krenz and I have had some
Mhm.
preliminary discussion about that.
Yeah, and two, so one thing, we've been doing these Friday night events and we were hoping to move the astronomy nights to Saturdays, but we're still exploring whether or not Friday night's going to be a mainstay for our evening programming or if it's going to change to Saturday or Sunday. So we're still figuring that out too. So Friday may not be a block off anymore for us.
We only meet on the third Friday anyway, so.
Mhm. But yeah, and then just to have you guys present there, we've kind of talked with the Student Astronomical Society. We've got that multi-purpose classroom space. Sometimes we do talks during our regular tours, but also sometimes it's kind of a passive space. So I'd love for it to become an active space where people get to engage with other astronomers and do something else with it. Yeah.
Should point out, our meetings have always been open to the public too, so Friday night meetings with Lowbrows could still be public events.
That's true. Yeah, I didn't
Yeah.
think about that. Yeah, we could
Yeah.
just say, hey, they're talking about space in here. They want you to come in and just make that part of the thing. Yeah,
Yeah.
that's a good idea. Yeah,
Okay.
cool. Well, I don't know. I'll drop my email in the chat. It's pretty simple. It's just my last name at umich.edu. Or you can contact us on the Detroit Observatory website. We also have a calendar there that has our sort of monthly programming. Right now, we're setting up September, and then our hope is by the end of the year, we'll actually be able to plan out ahead quarterly. So every 3 months, we'll have a full 3-month schedule out so that we can plan further up for stuff like this. Make it more comfortable changing schedules.
Excellent.
Awesome. Well, thank you so much,
Okay.
everybody. Thank you, Lowbrow.
you.
Thanks for joining. Yeah.
Okay.
Here's your mic.
All right. We will move on to the business part of the meeting. And I've got a few things here. I'll try to move through them kind of quickly. As we were just hearing about the Student Astronomical Society, it's actually good timing because Shannon mentioned me earlier today that they are doing an open house. Has anybody looked at outside and knows what the weather is? But anyway, I believe they're doing an open house as we speak. So you could go on up there right after the meeting and see it, but I don't know what the weather is. So, but if it's good, they're up there. Also, Norb Vance sent an email and said that they're doing a thing over at Scherzer Observatory also, same time, so a little further away though. Also, on the event front, looks like we're headed for perhaps a very, very busy October. We have 3 open houses scheduled as it is now. We, of course, got one of the third Friday as our meeting night. Tecumseh Parks and Recreation, I sent an email about that, and I did actually get myself and 4 other people that believe they can make it, and that actually would probably be enough to cover, and we can always use more, but I think that's enough that I can say that, yes, we can actually go ahead and do that, and they were looking at October 14th, which I believe was a Friday night, as I recall. Also, earlier than that, I had mentioned that we had a request for a return to Westland Library, which I actually did schedule, and that is for September 30th, as I recall. Trying to pick that off here. I'll say that until I can correct myself, but yeah, I'm pretty sure it is. Unfortunately, I believe, unless I've lost track here, that myself and Jeff are the only ones that have volunteered for that one, and we definitely need more people for that one. If it goes like it was in the past, they had a pretty big crowd there. Yeah, I think you were there, Jack. You know what I mean? There were.
I felt there too.
Yeah, exactly. And what, did you say something about going out to it? I think you did, didn't you?
Oh, yeah.
Okay, I didn't get your name. Thank you. Make that 4 of us so far then.
I remember.
Yeah.
I'm planning on it
Yes,
also.
thanks. Well, like I said, I might have lost track of something, so. But I'm gonna bug everybody again about getting some more, because again, I think the events that we did before, we probably had what, a few hundred people? Something like that. It was a pretty big crowd came through there, so we had a lot of scopes and they were all busy. Not to say it's gonna be that way again, but I would figure it might be, so. Also, I have been working with another group that's a land conservation group. And they were talking about scheduling something. The last word was, guess what? They want to do something in October too. However, about a week ago, which was the last contact I had with them, they said that they were having a meeting and were going to decide whether they were going to request that or they were going to wait and try to do something next year. Being that I haven't heard anything more, I'm guessing that they've decided next year. But I'm going to touch base over the weekend and see if they've made a decision or not. Because if they really want to do something in October, it's going to be a little hard to try to squeeze that in there. So it's kind of an interesting concept, though, because they have different parcels of land that they have preserved. I think some of them are Washtenaw County, some of them may not be. I saw a list of them. I don't remember all where they are, but a lot of them are in very rural type areas. And that was kind of what they were thinking, is it would be cool if we could do some kind of a star party event at one of these places. Of course, we'd want to have one that's a darker area and then work out, you know, what's the venue like? Is it practical to do that? But it's a really cool idea and concept because it would be an opportunity for us, and for them, it kind of highlights in this way the, you know, why we want to preserve land. So I'll keep your prize on that. Again, it could be they're going to wait until next year, but we'll see. And if that wasn't enough, then we also got a request from the Student Astronomical Society to do an event for them. This would be kind of like what we were doing for the Michigan Math and Science Scholars, but for the Student Astronomical Society. Anybody want to guess when they want to do that? October. But as it turns out, Shannon is very flexible with that. We could do a weeknight event. I think I'd have to look. She sent me another email earlier today. I think it was Tuesday is the best nights for them if we did that. But she said they really wouldn't have a big issue if they just piggybacked on one of our open houses that we scheduled anyway. So I'll continue to have some dialogue and see. We might have to do that just because we're getting kind of stretched. So, but I would like to do something for them. And if we could do something just for them, I think that would be nice. But I think we should do something no matter what. So again, part of building those relationships. So, because as Austin said, there are really 3 big astronomy groups in this area. And they're one of them, Detroit Observatory, one, and us. So it'd be nice to keep that going. And I think, yes, that was all I had. So I will move on to other officers, and since Jeff is beside me.
Okay. Well, tonight we had, everybody hear that okay?
We had 29 maximum, and that breaks out to be 22 max on Zoom and 7 for the in-person. I'm going to make a case for the
Astronomy at the beach, which I will share a beautiful
poster
that
Brian made up for us. Just a quick reminder that Astronomy at the Beach is on September 16th and 17th. It's going to run from looks like 4 p.m. for all the solar stuff to run, you know, before the sun goes down behind the trees, up till probably 11 or midnight. Officially, I think it's 11, but people have been advertising midnight. And we have a survey, and the URL is in the chat for any lowbrows who want to come out for that night. I think currently I got 10 that filled out the survey and says they can make it. We'd love to have a good lowbrow showing there, and it's just setting up your telescopes in the field. We are going to try to maintain decent distancing for stuff for COVID purposes. Officially, the DNR can't enforce any masking or vaccination cards or any of that kind of stuff. So
it's more or less, you know, if you feel strongly, you have to, you know, request that people do that, but you can't expect them to actually follow through. But that's the official thing, but we're going to try to space all the telescopes out so that they're well spaced. Friday is typically a slower night than Saturday because obviously it's a work week. But according to the Lowbrow maps, we've got about equal people for Saturday and or for Friday and Saturday. So September 16th and 17th, 4 p.m. to midnight, and bring all your scopes and stuff you want to come out. So that's my spiel. I think I covered everything I can think of. We have speakers. I believe that the Lowbrow meeting is not going to happen that Friday night, and that our speaker, Nicole Zellner, is going to be speaking at Astronomy at the Beach both Friday and Saturday night. Different topics both nights, so you can have a good reason to come out for both of them too. So I think that's it. Any information, get a hold of me or Adrian or John Wallbank. We can all give you tons of information, or just contact the GLAC people. There's a bunch of people to answer a ton of questions. That's it.
Okay, thank you, Jeff. I'm going to switch screens here just so I can see who all, thank you, is here. So I will move to Jim Forrester.
We've had another 3 or 4 nights on Peach Mountain since the last meeting, and a couple of nights in Leslie Park in Ann Arbor staring at the moon. And there's been not a huge turnout, but a steady turnout of 5 to 8 people every night. So it's been a lot of fun. And this month has been a lot of clouds. And tonight, which is actually pretty good, we are having our meeting. So no observing tonight, but but next week, I think there'll be a couple of nights that we'll be able to open up for the members again. As for tomorrow night's open house, I don't think the weather gods are smiling on us at all. But the long range forecast for a week from Saturday is promising. And that's all I've got.
And thanks for mentioning that, Jim, because I knew I was forgetting something, and it was the open house, since I volunteered to be open house coordinator for the 20th. And it could be, it's going to be a real easy job for me. So, although to be honest, sometimes the hardest part of the job is trying to make the weather call, but I got a feeling that's going to be easy too. In fact, really, I think maybe even later tonight or tomorrow morning, if I don't see some reason to think it's going to change tomorrow night, I might just go ahead and update the hotline and send the email canceling it, so people can get on with the weekend, because it does look pretty hopeless. So
yeah,
unless we want to go out there and watch lightning or something.
Yeah, I usually give a look at the, at the satellite that
Right.
the Weather Service puts up to help me make a call if I want to make it early in the day. Because usually you'll see that big blob of whatever coming at us in the satellite by sunrise tomorrow morning.
Yep, thank you. Okay, how about the man doing the minutes for us tonight, Dave?
Sure. One thought I had, we had any contact with the Hands-On Museum?
No, not for
Okay.
a long time.
Okay, I'll try to contact them just to touch base. I mean, we're not making any commitment quite yet, but please touch base with them.
Yeah, that'd be nice, because we used to do things over there every once in a while. It's been, geez.
Yeah, it's been years.
Years, exactly. Yeah. Yeah, excellent idea, Dave. Appreciate it.
Okay.
So, okay, thank you. Anything else?
No.
Okay. Our treasurer, Doug, as you notice, was not able to be with us tonight, but he did send an email, and he's got 2 things to report. We have members and we have money. Yeah. Pretty easy, huh? And I believe that brings up you, Jack.
You want me to? Okay, basically, We've been working out the observatory and that's ready for our open house. This is going to be the first one in 2.5 years. We also got the new battery charger for the 17.5 Dob. Got that taken care of and set up. Me and Dave Jorgensen did that during the week. And we did some road work on that famous rut on the 2-track dirt road coming up to the observatory. We leveled it out with some rock in it, so driving down there will be a lot easier. And that's about it what I've got for the observatory for right now. Okay.
Thank you, Jack.
Okay.
That's all the officers we have tonight. So does anybody have anything else? The one thing I can think I was going to mention, but it is getting kind of late, so we can do this maybe via email. But Jeff had sent out an email earlier regarding COVID policy, because as it turns out, even now, our policy actually is stricter than what the U of M policy is. Not to say we can't do that, but it's something to think about. The other thing to consider is in about 2 weeks, the U of M is going to update their policy. We don't know what that is. My guess is probably it would loosen from what it is more so than go the other way. But in fact, I don't know, maybe a good idea to wait a couple weeks and see what they say first. So
Well,
the only thing between now and then is AAT being,
yeah,
you know, assignment at the beach.
the last one that I sent from the chief medical officer of UNM, and it was
from the Dr. Ernst, from the chief medical officer of U of M. And it basically said that they're following the CDC and Washtenaw County guidelines, which basically say that masking indoors is not necessary, but recommended. And everything else is at, however you feel individually. They encourage masking and distancing, but they're not mandating anything. They're not recommending anything unless you're indoors. So it's pretty loose compared to what they've done in the past. I didn't know about the 2-week thing one way or another. I might have not read that closely enough.
Did I read that in your email? I saw that somewhere, I thought.
It might have been an earlier one, but Dr. Ernst just came out.
Oh, it
today or
was,
yesterday.
yes, it was the earlier one. Yeah,
Right.
yeah, you got it. So,
Dr. Ernst is probably the definitive one compared to
Okay.
the previous site. But
Right.
I try to pass those on to officers
whenever I can, so we can
discuss
discuss
them,
about it.
figure out what we're gonna do.
okay, bottom line, we'll have some further discussion about that, which is something probably we just expect anyway as the situation continues to evolve. So, and hopefully for the better, but anybody have anything else?
One thing on COVID, at the present rate of daily deaths from the virus, 130,000 people are going to die from it in the next year. And I hardly think that that's anything approaching it's gone away. Whatever we can do for our little world to help people stay safe, I think we should do it. Masking at the meetings for the people that come to the in-person meetings and at the member nights and open house. I think we should continue to do that to the best of our ability. And I'm pretty well convinced that most of what we're getting from officialdom is more politics than epidemiology. And I'm frankly pretty disheartened and disgusted by the current recommendations coming out of the university. That's my rant. So there you go.
Got it. Anybody else? In that case, do I hear a motion to adjourn? Anybody opposed? Okay, everybody have a good rest of the weekend. And we'll see you at Astronomy at the beach in about a month. Thank you.
Good night, everyone.
Good night.